IACT, the Inventors Association of Connecticut, is proud to present Attorney John Yankovich discussing the Supreme Court patent ruling Bilski v. Capos from our meeting on August 31st, 2010. Our meetings are open to the public, and we hope you'll consider joining. You can do that by going to inventus.org and clicking on the Join button on the front page.
Okay, good evening, everybody. My name is John Yankovich, and ordinarily I'm just a member of the audience. But this evening, our speaker is stuck in traffic, so I'm filling in. I'm a patent attorney, and I know a bit about the subject, and in particular, the Bilski case. I would like to say that this topic of Bilski is really a limited topic. It's not something that most inventors for most products should have to worry about. And by that, I mean most people who invent something, they've been working at work, and they've done something physical, and they have some physical improvement to something that they already have a machine, they already have their process, they already are doing something, and they've improved upon it. Okay? And this idea of now having some piece of software that's just sitting around by itself, and a method that's just in the abstract, is something that occurs not infrequently, but most people, when they've invented something, really do have something that will safely fall into one of the other categories anyway. And I will explain that further as we get to my examples down here. Yes, sir?
So what's the significance of this case if it hasn't been revealed?
Well, the significance is still, actually there's a history to it. You know, a history meaning that somebody filed a patent application, I think it was in the late 1990s, roughly 10 or so years ago. That application was examined by an examiner at the U.S. Patent and Trademark Office, probably over a series of several years. The claims, and I assume you guys know what I mean by the phrase patent claims. The claims were ultimately, and if you don't, but we can get into that too, were rejected, and the applicant appealed to the Board of Appeals in the Patent Office. The Board of Appeals rejected the claims. And so the applicant took it out of the Patent Office and presented it as a litigation, okay, as a civil case to the probably the district court or Court of Appeals for the Federal Circuit, okay, and ultimately through a series of appeals it went all the way up to the U.S. Supreme Court.
So he would never get the patent?
Oh, he never did get the patent, right? Still hasn't yet. Okay. Just so you know, that's the end of the story. Hasn't gotten a patent, and I'll explain why he hasn't gotten a patent. Yes, sir.
Yeah. Let's see a specific case. Okay. Actually, Nyquist diagram. Nyquist.
For sampling. For sample theory.
No, for the closed loop control. When the that's really enabling all the long distance transmission.
Okay.
Okay.
I'm not specifically familiar with what you're talking about.
Basically, his idea.
Okay.
Basically, his idea. When it's a feedback. Basically, you lose a signal, they go coming back. Mm-hmm. Using the negative feedback.
Okay. So Nyquist had some kind of circuit with an amplifier in it.
Yeah, it's called a Nyquist diagram.
Okay. There we have it. All right.
All right. So this idea itself has been actually used in different levels. The concept of closed loop can be used in the governance or control, command control.
Okay.
So if it is used in a command control architecture strategy, and also develop into a doctrine. A doctrine, how do you control it, in the operation.
Yeah. What's a doctrine?
Doctrine. Yeah, doctrine. So, and also you can get into a, mathematical. It's a mathematical formula. Mm-hmm. Then you can get into a algorithm. Then you can get into the circuits.
Yes.
Actually, all the things. So, how is that using that as it's an abstraction. It's an abstraction of a natural phenomena.
Right, and let me make sure I understand the question. So, and I might be dealing with that here.
But
But
yes,
let me try to illustrate what you're talking about. There's some kind of theory,
Yeah.
mathematically, that Nyquist
Yeah.
thought of, okay?
Right.
And he applied that to a circuit. By using that, he developed a circuit.
Yes.
Okay, and here I'll draw the circuit. This is just a representative electrical circuit.
Right.
And the circuit in turn controls, that is a control for some,
Yeah. Control the error
Some
of
device.
transmission. Yeah. Signal errors.
okay, signal error, so it further controls some other circuit,
Yeah.
in your example
Right.
there. Or a device, okay?
Right.
So it controls some other circuit or device.
Right. This is before the software age. So this was originally
So there's no
hardware.
software here.
Right, but
Okay.
it can be implemented in the software.
Yeah.
So I want to use
Yeah.
that as a case to.
Now, even in this example, now this is a pretty easy example as to where the question here, the implied question is, given the idea of the concept of Nyquist theory, whatever
Yeah,
that
negative
is,
feedback loop. Yes.
okay, an embodiment of it is a circuit, and
Yeah.
then the circuit in turn controlling something else. The question he's implying here is, where is the dividing line between something that's not patentable and something that's patentable? This is an easy one. The dividing line is right here. Okay? Yes. The mathematical algorithm itself, that does nothing where.
It's
I'm going to
abstraction.
get to it. Let's leave this for now.
Okay.
And later on this evening, when we're over here, we'll be talking about that at the same
Sure.
time.
Thank you.
Okay? Are there any more questions before I go on? Okay. So fine. I've been through the 4 M's. I mentioned several, and this is for my own benefit, so I can keep track of where I am here. I mentioned several categories of non-patentable subject matter, which on their face are non-patentable. And so then we have Bilski, who came along and wanted to try to patent something I believe is a method for evaluating some kind of risk having to do with business. Okay, where meaning that in Bilski it was something like he received some input, some numbers, some kind of parameters regarding operation of one or more businesses. He fooled around with it with some kind of algorithm, came up with a result, and the result just resided in the computer. Well, I drew this sequence of events happening in the history of the Bilski case. Somewhere in there, somewhere at one of those, some decision point, I believe it was at the U.S. Patent and Trademark Office. That doesn't even matter who it was. Somebody came up with this rule that says, for a method to be patentable, although it's, according to this, a method should be patentable, just on its face. But they said just a naked method by itself is not patentable unless that method is tied to a machine, particular machine, as they say, or causes a transformation of material. By being tied, so this was known as the machine or transformation test, MOT, machine or transformation. Meaning, by way of example, and this is particularly relevant in the arena of software. And even Bilski is probably something that was meant to be employed in a computer. Okay? And so Bilski brought in the idea, created this anxiety in the software industry with regard to thousands of people who have filed patent applications directed toward software products. And many of them have issued patents that have issued for their software products. So this made the group with the issued patents really nervous, because if the U.S. Supreme Court ultimately held that the machine or transformation test was the test, and somebody with an issued patent had some software that was not affirmatively tied to a particular machine and did not cause a transformation of material, material, or a transformation of data that represents a real-world material, then those patents could be invalidated. And all these people who have already filed their applications, pending applications, and spent lots of money on their pending applications are now kind of walking a fine line. So the U.S. Supreme Court had to decide, and this is what happened in the course of the last year or so, year and a half or so, had to decide whether the machine or transformation test was the test for determining whether a method, and even more specifically, a piece of software as one embodiment of the method, had to meet the machine or transformation test. The U.S. Supreme Court in June of 2010 held that that is not the exclusive test. In other words, it is not necessary that a method or a piece of software satisfy the machine or transformation test. It is not necessary. However, the U.S. Supreme Court nevertheless held that Bilski's patent claims directed to the method of evaluating risk, and don't hold me to this, I don't remember if it's a method of evaluating risk, but it's some business method. The U.S. Supreme Court still held that Bilski's claims are not patentable because the idea itself, or the method itself, was merely an abstraction. It was something that, I believe they used this language in the opinion, it is something that was merely a series of mental steps. It was something that could be performed in the mind of a human being. So, back to my non-patentable method here. This is my example of a non-patentable method. If somebody merely presents me with some information about business, I think about, multiply it. Maybe I need a little cheat sheet, and I might have to do it on a piece of paper. And I get a result, and the result is merely in my head. So all of these steps in my head, or can do all those steps in my head, then it'd be considered an abstraction and
But
not
wait a second.
patentable.
Doesn't it matter that these abstractions that comprise, let's say, 100 steps that could be done in one's brain can't be done thousands of times a second in a man's brain?
Doesn't matter. I call it the big head. The big head. Okay. It's not realistically that we're saying that it's really done in the mind of a human being. Okay. But rather, by way of example, if it can be done in the mind of a human being. And in most patent claims, now I'm glad you asked the question. And I'm about to go a little bit off topic here. I'm still going to be talking about patents. But I'm going to be talking about, for the next couple of minutes, drafting a patent claim versus what you might actually do in the real world with your invention. Yes, sir.
So before you go off on that, just a very quick question. When you say do it in the head, does that exclude the possibility of using a pencil and paper?
No. If you could do it in your head with just the assistance of paper and pencil, we'll make somebody with a really big head where they don't need pencil and paper.
Can I ask the obvious question? Is there anything that a computer can do that cannot be done in principle with a pencil and paper?
The answer is no.
Yes, it can transform. I'm going to answer your question, but I don't want to lose track of what I'm going to say too. Yes, what can a computer do? With regard to a transformation of material, or a transformation of data that represents a real-world material, the relatively recent example of something that happens purely in software that is patentable. The example is receiving data, and I'm going to use this same flow chart, but we're going to come up with a result that says I am patentable. It's a piece of software that received data that represented an image. actually represented data from the ultrasound. And the algorithm that it performed was to transform those points of data from the ultrasound into some form of image data, a new type of data that could be presented on a display. Okay? I believe I'm answering your question. The question is there something that can be done in the mind or...
In principle, that could be done with a pen and paper. It might take you 2 years.
Yeah, but the point here isn't whether it would take you 2 years or whether it would be done in a picosecond or a few microseconds versus it might take you a year to do the same thing. Okay, that isn't the issue here. The issue with regard to this abstract is if it can be done in the, theoretically, hypothetically, in the mind of a human being, then it would be considered an abstraction and not patentable. Yes?
So let me see if I can create an example of something that's not patentable according to this definition.
Yes.
Suppose I write a program that does what a radiographer does, operates very quickly, and identifies cancer. Right? You're saying that's not patentable because radiographers can do this in their mind.
I believe you are... I don't know the answer to your question.
Okay.
That's a very good example, or that's a good question. That's a good one.
Because I like to make computers do what people can do.
Here I just gave you an example of transforming signal data into image data.
Right.
Okay? And so what you're actually talking about is the same thing.
Pattern identification.
That's actually not true.
Well,
The radiographer will not, I'm sorry, this is my domain. The radiographer will not say something is cancer or not just by looking at an image. That image has to be substantiated by a pathologist for them to say it's cancer. Biopsy.
So let's say we use some sort of other technology like laser-induced autofluorescence to identify cancer, and we find a way to do what can be done in a person's mind.
Include that it's cancer,
Yeah.
at least to flag it as
Yeah.
possible.
Or possible cancer.
Yeah.
So now it sounds like because it's doing this pattern identification automatically, but it could be done in somebody's mind, I couldn't patent it.
I don't know. I'm going to say that something like that, pattern identification and coming up with a recognition of something other than the original data itself, other than just moving data around and coming up with some data result. This idea of producing an image, I think, even under the Bilski, the earlier Bilski machine and transformation test, is at least getting close, if not actually making it over the hurdle of being a transformation of data, possibly. But this is all of these things that you're talking about now. This is where this line, the Bilski line, and we don't even have to call it the Bilski line, but for convenience, the idea of patentability of a method is a not well-defined line, even post-Bilski, right? Even as a result of this Supreme Court opinion. I'm still not quite sure of where the line is, but I still have some guidance.
Yeah. Isn't this because the whole thing is because at that time it's really called the business process. You remember the time a lot of people abuse it because the definition of business process because with the internet and the software, a lot of people rush into patent, like a business process. Mm-hmm. So this have significant consequence that exclude other people.
Yeah.
All right. So because business, so-called business, dealing with dollars and profit, does that involve with beyond this kind of abstraction?
Okay. Good question. And let me provide a little bit more background here.
Right.
Bilski, of course, is a business method. Okay. There is no definition of a business method. There's no definition in the U.S. Patent and Trademark Office of something that is a business method, okay? Because arguably almost every method that you employ is somehow related to business of some kind. But by business method patents, when we talk about that as patent attorneys, we're talking about those things that are pretty much exclusively concerning a way of selling something, evaluating the target market, dealing with clients, and doing something that really doesn't necessarily involve technology, as we think, even though the method itself may somehow involve a computer, such as Bilski's involving the evaluation of risk. But it was those things that pretty much on their face. It was like trying to patent a manner of doing business among people, or
reverse auction.
Yes, auctioning, reverse auctions. Okay, and an auction itself is not patentable. However, if you execute the auction on the internet, using communication devices, that is patentable. But the auction itself is not patentable. All right. I know that there are a few other questions here. Are the questions still there? Are they relevant to what we're talking about right now?
I guess this is a very compelling issue. Usually when you get a ruling from the Supreme Court, it's supposed to add some clarity.
No, yes, you would think so.
You would think,
particularly as a taxpayer, you would want that.
It's supposed to teach everybody, this is the way you got to handle it.
No, this satisfied nobody.
That's absolutely right.
The Bilski ruling satisfied nobody.
Right.
Except I still have my own rules, and it doesn't bother me. I don't worry about all this stuff, to tell you the truth. And I'll explain why. But go ahead.
Just a potential example for you to wrap your mind around for a moment. Let's say a business uses a certain type of a program or a series of programs to run certain aspects of its operations. And the software vendor puts out an application programming interface.
I'd like to ask one clarification here. When you say it operates some or run certain aspects of its operations.
Financial transactions.
Okay, to coordinate transactions? To move, okay.
Yeah. So business software. And the software vendor sets out application programming interfaces, ways that users can interact with this program, access data, and so forth. So there's a whole scheme of potential operations you can do with this interface. And what if you've come up with a particular way to, say, push a series of buttons in a certain way, do certain operations that is unique? Is that patentable? Is the way to uniquely tweak a programming interface from a software?
I'm going to say yes, because that is something that pushing of buttons, and particularly as part of the user interface, is something that is not going to be executed just in the mind of a human being. It's going to involve some kind of display, some kind of input device. Okay. Correct?
Yes.
I just want to make sure I understand the question. So, I believe, for the example that you've given, I believe that that's something that would be patentable without too much concern. Okay. Any other question? Yes.
I'm not sure. My belief is that the RSA public key algorithm was patented. And that is nothing but a mathematical description.
Yep. So is Huff transforms from the 60s.
Yep, you're probably
How
correct.
did they get a patent? I never did figure that out.
Good question. I don't know. Right, could it be?
At one point, they were giving patents for everything in software.
Okay, but it depends on how the patent claims for the algorithm are written also. And it might not, because arguably, if it is just a series of mathematical steps, in other words, we'll start with a kernel, okay, and do something with that kernel and come out with another number. Start with the first number, do something to it, and come out with another number. That is just a mathematical algorithm on its face, and that's not patentable. But if the claims are written such that it reads a first computer file, does something to generate this key, and then encodes that computer file to produce a second computer file, then that would be patentable. But I really can't answer the question because I don't know the answer. I'm not familiar with the patent you're talking about or the claims.
I'm
explaining how it could be patentable anyway.
Yeah, I've watched it for 20 odd years, and I think that nobody has a clear definition. Because the point was raised before, theoretically, anything a computer can do, a human being with a big enough piece of paper can also do.
I had an example.
Well, you were almost correct. Yes, yes. In fact, yeah, you are correct. Yes. If we're looking at just the processor and the memory, this is the mechanical equivalent of the human brain. Okay. So, yes.
The example I was thinking of before, I like to look at the website Astronomy Picture of the Day. I just love this stuff. I go there. Midnight they change it. Every day there's another picture. It's amazing to see. The things that I see almost every night cannot be done if you had all the time in the world and all the people on Earth working on this. You wouldn't be able to see those images. It requires a technology to enhance things that are either so far away or not visible using our normal senses. And I'm guessing, I don't know who owns the rights to these space telescopes, whether there's patentable material, and was government funded for most of these things. I'm guessing that would fall, these images that I see, that any of us can see, would fall into the category of what you're talking about, of something that a computer can do that human beings cannot do.
So that's purely because of speed. Purely because of speed.
It's only speed and size. And
Right.
reverse, anything you can do can be created on a scale so big that you couldn't in one lifetime.
But maybe that is a rule, if a human being does not do it.
Yeah, well, that isn't the rule.
That isn't the rule.
You may recall, roughly 10 minutes ago, I said I wanted to divert for a moment, okay? And talk about patent claims.
I have to tell you, in this group, when you do a diversion, don't try to fix 10 minutes.
I'm trying to go back where I said I wanted to talk about a patent claim because this gentleman talked about something that involved millions of operations per second or something like that, that a human being couldn't possibly do. And this has nothing to do with Bilski per se, okay? But rather, when drafting a patent claim, even though your invention, whatever your invention is, may involve millions of operations per second, may involve communications with thousands of people and lots of things, and things happening so fast the human being can't even fathom it. That big operation, all that activity is not the invention that you would ordinarily want to claim in your patent claims. Instead, when you're drafting a patent claim, you want to go for the most basic, simple, naked representation of the activity that's occurring here in this invention, in this product. So although your product may involve, again, thousands of operations, if possible, and let's say that it's a communication system that involves with a server, okay, that involves a server that has potential ability to communicate with thousands of client devices out in the internet somewhere. And what your invention is a compression algorithm. Compression algorithm to fit more information into data packets. And since you're able to fit more information into a data packet, you can communicate with many more client devices than someone could before your invention. Nevertheless, when drafting a patent claim directed toward that concept, you only want to involve this one server and its ability to fabricate if possible, one data packet and send that one data packet out into space. In other words, or out into the internet. In other words, the point I'm making here is even though your product may involve the ability to communicate with many, many devices for purposes of a patent claim, you only want to talk about it in the context of its most simple components, meaning, in my example here, the ability to encode a single data packet send out that same day. And that's what you draft your
Is
patent
it by
claim.
inference that you're saying that Bilski's ills could have been cured by crafty claims writing?
Well, perhaps, and perhaps. I don't know what Bilski's claims are, but the answer is probably yes, or at least possibly yes. Okay. Let me. So we've gone through here. We've talked about Bilski, and to reiterate, prior to the U.S. Supreme Court hearing it, the test was the Machiner transformation test. The U.S. Supreme Court decided that the Machiner transformation test is not the sole single test for patentable subject matter of a method, but it is a clue. Let's go over here. The Machiner transformation test is a clue, meaning, and this is their present guidance at the U.S. Patent and Trademark Office, present guidance given to the examiners, is, in fact, let me before I get into that, let me first mention a couple of other criteria for patentability, which you've probably all heard before. Over here I talked subject matter. What are the things that qualify as patentable subject matter? Now, assuming that we get over that hump, okay, whatever your invention is, has to satisfy at least two other criteria. It must be new. Your invention must be new, novelty, and non-obvious. New meaning you're the first, for purposes of this discussion, first to invent. Non-obvious meaning that the difference between what you have and what went before is not a mere alteration that anyone skilled in the art would have thought of. Novelty is evaluated based on printed publications. So, for example, you file a patent application directed toward the data packet algorithm or data packet compression that I mentioned earlier. The U.S. Patent and Trademark Office examiner will look at, for example, other patents and see if there's any description of something that appears to be the same as your invention. Okay? That's the criteria for novelty. Non-obviousness might be trying to wing this, again, the data packet idea. Let's say that the data packet here involved a series of operations of converting or transforming ones to zeros. And the examiner finds a reference that actually produces the same result, but instead of going from ones to zeros, it converts zeros to ones. Arguably, anyone skilled in the art would know that you can convert one way or the other and come up with a similar result. Okay, so non-obviousness means that when an examiner says that your claimed invention is obvious in view of the prior art, the examiner is saying, okay, you got me. It's new. I can't find anything dead on that shows that this has been done before. But the stuff that I have is so close that you're obvious in view of it. You invented a red wagon, I found a blue wagon. Okay, it's the same thing. All right? You've invented a table with 6 legs, but I can show you tables with 1, 2, 3, 4, and 5 legs. Having a 6th leg would be obvious in view of the prior art. So, what the U.S. Supreme Court said was that the Machiner transformation test is a clue to non-patentability. Because if something doesn't satisfy the old Machiner transformation test, that should at least raise a flag in the eyes of the examiner. Because if it's not tied to a particular machine and it doesn't transform any material, what the heck does it do? Because the present rule is, as far as I'm concerned, is that whatever the method is, as we've been talking about and trying to define for a while here, it must not be a pure abstraction. It must not be something that is merely a sequence of mental steps. in my example, by example, it shouldn't be a method that can be fully performed in the head of a human being, even if that requires that human being to have a very big head to keep track of things. Okay? So, by way of illustration, for most cases, now here I have a computer system of some kind, a system that includes a processor, a memory with a program embedded therein, an input, and then some outputs here. Okay? Forget about business methods. I don't want to talk about those anymore. The more realistic concern that we have, most of us, when we're worried about this Bilski problem and the patentability of methods, we're usually talking about software. So, you draw your invention. Ordinarily, your software, you have some flow chart of some kind. And then draw a physical embodiment of your system. Ordinarily, it would involve a processor and a memory with your program represented inside of your memory. It is almost definitely going to be, well, not almost definitely, in many, many cases, if you're just trying to claim, in fact, let's not even include the processor, trying to just include a thing that is inside the memory, just that series of steps there, or more specifically, this method that's being executed inside that memory, so that it doesn't have any impact on the external world, it's probably going to be considered non-patentable, because that process could be executed inside the mind of a human being. However, so the issue is still then, okay, I've got a good idea. I've got the radiology system, okay?
Yeah, let me revise that. Because it was a company which was in Milford, and they were examining bad ball bearings as they were coming into production. And they had a person sitting there, and they would kick out the bad ball bearings, and I said, I can write a program to do that for you automatically. Just kick out the bad ball bearings. Here's an algorithm that'll identify bad ball bearings. Forget cancer. And now it's clear that that algorithm, from what you've said, would not be patentable.
Your problem, I don't know. Okay, again, I just don't know. Because I'm listening to that, and I'm saying to myself, I would want that to be patentable. Yeah. I would really want that, even if it were just in here, okay? But that's a method of you're receiving data about ball bearings. I guess image data, light data representing
that's just
reflection.
pattern matching. It can't be been there, done that.
Well, maybe there's some unique algorithm that I have for identifying ball bearings that are bad. And so I would like to patent my algorithm.
Every version of it is some form of pattern matching.
Well,
but it's a hypothetical.
Maybe it's the way. Just to make it realistic, maybe it's the way that the light scatters off. Sure. So you have a button. Not only do you have a beam that's incident on the ball bearing, but a plurality of sensors, and you detect the angles at which the light scatters off of it. Just for the sake of an example here, okay. So in your example, you're just receiving input, that being the scattered light, evaluating it, and based on maybe intensities of the light over the surface of your array of sensors, you're able to make a determination as to whether it is a good ball bearing or a bad ball bearing. I'll tell you that the U.S. Patent and Trademark Office would be reluctant to give a patent just on that. Okay, just a method, just having something that is, claim one, a method comprising those steps. Okay. Again, it's because of the word method here. That kind of brings up the problem.
If you specifically define that the scatter light in certain directions has to be more than within range and so forth, then I believe I've seen patents which are fairly specific in what you have to look for. They may also be useless, but is that considered patentable? You're fairly specific, not just with how you illuminate it, how you look at it.
Okay, you've just said how you illuminate it. That's different, okay? If instead of, and I'm kind of going to try to wiggle out of this, okay? Because I don't have answers to the fine questions here. So I'm going to take a kind of an easy way out. I'm going to move away from just the pure method, because I don't really know whether that pure method in our example here would be patentable or not. Because it sounds like it should be. It sounds to me like you're almost on the line of transforming data, image data or light data that represents light, into some kind of structural representation of, maybe not structural representation, but some other representation of data that indicates the goodness or the badness of the ball bearing. But if you instead had a system that included, now, instead of just a method comprising those series of steps, instead a system, okay, a system comprising, and just, I'm going to add something to here, okay, a light source, detector, and a processor. Let's say maybe the detector, a light source for producing a beam of light incident on a target, detector that detects a reflection of the light from said target, and a processor that receives a signal from the detector and does something with it. And here's the same method that we've been talking about, the same series of method steps, and we just put them right in here. But this is certainly patentable.
Yeah, a system is different from a basic method patent, which was
Yes.
what I was trying to get at. And that's where the invention is from my point of view, because just having a light source with a camera and something that kicks out a ball bearing doesn't strike me as being general enough. It's so specific as to be almost useless and easily engineered around. Mm-hmm. So what I'm looking for is the basic method patent that's most powerful and
very good. And this is
valuable.
Also similar to what I was mentioning roughly 10 or 15 minutes ago, where we want to go after the most basic representation of what your invention is. Even when drafting patent claims, even a system claim, you want to try to include as few components as possible. If you can possibly get away without including a light source, without including the detector, and in fact, even in this case, really all we really want is a processor and a memory that contains instructions that are readable by the processor and that control the processor to perform the steps of evaluating the ball bearings.
Now, in this case, what you've done is that A is probably the real knowledge, is the real novelty, but in order to get a patent, you've cloaked it into a device patent, number 2.
Yes.
Does that work?
In most cases, yes. In most cases, yes. And that's why, I see the hand there, and that's why, that was one of the things that I do regularly. And it seems to me almost silly.
It is.
It is almost silly, but it means that I'm no longer in the mere abstract. I'm no longer merely trying to claim something that could be performed in the head of a human being. But now I have something that's really tangible. I have a system, and that system is defined by a processor and a memory that contains instructions for controlling the processor to do the evaluation. And let me just say, hold your thought. In most cases, this is not harmful. This is not being too narrow, because in most cases, that is what you have. That is the thing that you are. That is your invention.
Why wouldn't the patent office see through your views and say, hey, number 2 just contains some ordinary components.
Very, very good.
Very simple components, and in this is this algorithm.
And you're right, because they do have when I say this usually works, it doesn't always. For some reason, it doesn't always. The Patent and Trademark Office is not consistent in the way they evaluate the patents. And one of the things that people have tried to do in the past is, let's say you have some unpatentable thing going on, and it doesn't evaluate ball bearings, okay? Let's say that it is a business method, good old BM, business method. And you're trying to, and the real result is risk, some risk number down here, okay? And you're trying to make it patentable by putting your risk result on a display, okay? This is innocuous post-solution device or something like that. That's some kind of phrase. This is not going to be patentable. Now, why should it therefore be patentable if I'm just saying that it's a processor? And I'm sorry, let's say that's the same thing here. A processor and a memory that contains instructions for controlling the processor to do something, and the result is a risk. Okay? All right? I really don't have an answer to the question. I know intuitively, though, that even this system won't be patentable because it's really, and I don't have an answer for this question, so it's really merely taking that series of steps that could be done in the mind of a human being and artificially putting them inside of a computer, okay? And therefore trying to claim that it's a system. But it's really doing nothing more. And the way I look at this is, ordinarily speaking, hold the questions, you can hold your hands at it. Ordinarily, if a method is not patentable, and I'm going to go right into a circle here, I know. If a method is not patentable, it shouldn't become patentable merely because you put it in a computer, as I've done here.
Yes.
Okay? So here we have this problem, though, this ball bearing solution. This is really a good invention. Okay? And it's not a business method, it's not just a risk, it's not just a number here. Okay? But really it comes up with a real useful result as to whether your ball bearing is good or bad. But my intuition is telling me that if I embodied it in a system of processor and memory, my intuition is telling me that I could get a patent on it. But if it only came up with a number that indicated a degree of goodness or degree of badness, I don't know where the line is here.
Yeah, because in this case, he is coming up with a number 0 or 1.
Yeah, you're right. It is. Exactly. So that's why I said I'm going to march myself right into a circle here. I don't really know. But so what I do, just practically speaking, what I do when I have a situation like this is I do have a system that includes inputs, that includes detectors, that includes the light beam, the light source, that includes a control device or some kind of output for bell going off to indicate good ball bearing or bad ball bearing, or perhaps something that controls the conveyor so that the good ball bearings go to the good box and the bad ones are kicked into the garbage.
I hate my example.
No, it's a good example.
It's a terrible example because it lets you design a system. Suppose it was just face recognition and it was better than anybody else's. And it could help you find terrorists in a non-standard warfare environment.
Fake it.
You know, it just says, oh, well, this guy is a known terrorist. I don't need a deck of cards anymore. I just point a picture at him.
That might fall into the transformation, argument.
It's just pattern recognition. It must be simple because it's just pattern recognition. But it's not so simple, and face recognition is still hard. And if I have the better algorithm, I can't patent it because all it does is it gives me a number that says, yeah, it's this guy.
I'm pretty certain that the pattern recognition, the face recognition will be patentable.
Yeah?
Will or not?
Will. Even though I know you're going to say I'd like to be done in the mind of the. In fact, we do it all the time.
We sure can.
We do
better than computers.
Better than computers, yes. Okay. I don't have an answer to your question, but I would feel comfortable writing a patent application directed to facial recognition. Okay.
Essentially, what it really comes down with is the entire patent system doesn't know how to deal with computers. And every decision is ad hoc. Nobody's got a set of rules.
That is also true. Yes, that's all. Now, by the way, we've been talking about the U.S. Patent and Trademark Office, the U.S. practice here. In other countries, they have more bright line rules. Well, what's the bright line rules? Like in the European Patent Office, software is not patentable in Europe. Okay, they just and there must be what they call a technical effect. A technical solution to a technical problem. Okay, so
copyright in Europe?
Yes, they have the copyright. Okay, protection. Okay, go ahead.
Yeah. Just say, if not just mathematical things, algorithms. So somebody come up with a totally new ideas, create idea which is not yet been discovered by, anybody else.
And by the way, hold on. I'm sorry. The idea of the facial recognition is really the data is representing some real world material, some real world something of substance.
But what about the big head test? I could do it in my head.
Okay, forget about the big head.
You don't like the test anymore? It's your test.
I changed my mind. I didn't like the Supreme
Then it's not an algorithm. Somebody created an idea.
Yeah.
The idea become useful because you have to communicate outside your brain to somebody else, like a boss. And we communicate with this common reference. We say, agree, this is a totally new idea. Nobody has it. And then from there you come an algorithm. And the algorithm is coming with like a face recognition method, all right? So the part about coming up with idea nobody else has, it's novel, right? Non-obvious things. Come up with an idea. I'll give you a sample. Okay, just say hypothetically nobody has come up with called fractional dimensions yet. Fractional dimensions.
Okay.
Because people used to say 2-dimensional events or 3 dimensions. We see they come up with a 2.5 dimensions.
Mathematically,
It's the Hausdorff-Besicovich dimension.
Fractional
dimensions.
Oh, okay. So it's
like in the
two-dimensional, three-dimensional.
Yeah, say you are the first one come up with that.
Okay.
So then that things itself, because nobody has come up with it.
Is that this over here? That's the
Right.
fractional dimension there?
Yeah, fractional state, that's it. Because now everybody knows that fractional dimension.
Okay.
But if you are the first one come up with that, and is that things patentable?
Probably not. It's
Okay.
a natural phenomenon.
Okay, so the strategy should be you converting the algorithms.
What?
In your computer, mathematical algorithms. And the algorithms will come up with implemented devices, so it become a part of the facial recognition.
If you use it in part of for facial recognition, okay, in where you're evaluating real world material,
Right.
okay, meaning the image of their face,
Right.
I believe that will be patentable.
Yeah, because you meet all your requirements. Nobody else has come in with the idea about the fractional dimensions.
Yeah.
Then it's not obvious. Then you're using that. From that, you get in the data, you can identify the fractional dimensions, and then you compare two pictures. Then you say, okay, this is the same. So, and then you put it into a devices rather than just to get a pattern before you have it. Just put it into a computer as a transformation. So the strategy should be go to the fourth step then before you apply for pattern or reveal to anybody else, right?
I didn't get the last of your...
Okay, so...
It sounded like you were coming to a recommendation at the end. I didn't follow that.
So I'm just saying, if you come up with one, first you come up with the idea, create it first. Nobody has that idea before.
Yeah.
And then you put that into a mathematical concept, formula, then come with the algorithm. The algorithms, instead of publish the algorithm, you put that algorithm into a computer code.
Yeah.
So that is enough to be patentable. Even before you have can you be used in the facial recognition?
Oh, no.
You have
That
to
would
get
not, no, it would still not be patentable. In other words, all you did was, back to your earlier suggestion about Nyquist, and instead of Nyquist, we're now talking about fractional dimensions. Okay? And you're saying that just now to put, to have that in a program that calculates the values of the fractional dimensions. Okay?
Yeah, and from the picture you can calculate the fractional dimensions.
Oh, okay, now you say from the picture. Okay?
Yes, you can calculate because the irregularity.
Since we're dealing with that real-world image, an image or data representing something in the real world,
right.
I believe you're patentable there. Okay, but if you just merely have thought of the mathematical principle itself, and you can represent it, and you're representing it in an equation, and you say, hey, my method is to receive a value and do these steps in it, and then get a different resultant value. That's not patentable. Okay?
But if you apply to something,
if you apply it to a real-world material, a real-world thing, and come up with your real-world result, then you're, and I think that satisfies the facial recognition.
Yeah. The risk
Even
of not being patentable.
even the ball bearings, okay? The ball bearings, okay? And the ball bearings and the facial recognition are really similar to one another. Just in one case you're recognizing facial features, and the other recognizing ball bearing features. Yes, sir.
The system part of your patent application is the reason why you want to limit, you want to put as few elements as possible. Is the reason why you're doing that to make as broad a patent as possible?
That's correct. If you have a patent claim, let's say you have a patent, an apparatus comprising elements A, B, C, and D. And let's say you have a patent claim that's been granted, you own that patent. For a competitor or for a person, for some other entity to be infringing that patent, that entity has to be practicing all of the elements of your patent. Elements A and B and C and D. It's called the all elements rule. So, if your competitor is not practicing all of A, B, C, and D, but is only doing A, B, and C, they are not an infringer. All right. So, the more things you have in your patent, the more opportunity your competitor has to not do something. And particularly, let's say you throw something really stupid in here. Okay. Let's say that we say that the light of, back to the ball bearing example. Let's say that we had to include a light beam in there, a light source. And what we do is we say that the light source is a frequency of a particular range. And you did that because who knows why you did that, all right? and your competitor is able to use a frequency of a different range, they would not be an infringer. Or let's say that we say that the light source is a laser, and instead of using a laser, somebody's able to do it with an incandescent bulb. Okay? It would not be an infringer. All right?
Also, now, in later claims, you want to add different embodiments of the original claim.
You mean, are you talking about dependent claims now? When you say later claims, you mean,
Yes.
in my example here, let's say that we have an apparatus comprising A, B, and C, and then 2, the apparatus of claim 1, of claim 1, further comprising D.
Yes.
Okay. So here's your where it said light source is a laser. So here you might have a light source here,
Right.
a detector, and then the processor doing all the other stuff.
Right.
And then the apparatus of claim 1 further comprising, or where it said light source A
Right.
is a laser.
Now, when you add such a dependent claim, you're not making it easier to you want to actually, maybe Mr. Meyer would be able to respond also. The goal is to get the patent. You want to throw enough in there to make it new and unique.
That is correct, yes. You want to throw enough in. Yeah, even though, by the way, earlier I was talking about throwing stuff in here for purposes of kind of guaranteeing that we had some patentable subject matter.
Right.
You're talking about something, a similar concept, making sure you have enough in your patent out. By the way, we are now not talking about Bilski or methods anymore. We're talking about patents in general. You want to make sure that you do want to include enough in there to distinguish over the prior art.
Yes.
Yeah, so that you have your point of novelty. Okay, you've been patient.
How do you in chemical patents, we distinguish the use of the term comprising as being a broader reciprocation than when you say a process comprising the steps of enumerate A, B, and C. You also have the phrase consisting of A, B, and C. A, B, and C is a much narrower claim than comprising. Do you have
yes, I understand that. By the way, I'm not a chemical engineer. I'm an electrical engineer.
I'm a chemical engineer.
Okay. And in your chemical patents, by the way, do we have people here who have chemical backgrounds? Okay. In your chemical patents, do you say a material or a compound comprising?
Yes.
A compound comprising? And you said
A, B, C.
Consisting of, or solution consisting of?
Right.
Solution
Consisting of.
consisting of, consisting, the important word.
That's much narrower than the
Of
first.
A and B and C.
Right.
And that means does that mean that's all it has?
Right.
Period. Okay?
Comprising is broader than
Yes, consisting is a word that, by the way, this is things only, like secrets that only patent attorneys know. Okay?
And then you've got the Marcouche group that you
That's even there, yeah,
chemical
that's some-
claims where you can have people that are not, and you can put in elements that are not necessarily
Yes.
related.
Marcouche group, we're getting off point here. Okay? If you guys want to talk about Marcouche groups, I'll be happy to do so. Okay? But the terms that we're talking about here are consisting means that whatever you're claiming is A and B and C, and that's it. Whereas comprising means A, B, and C, and could have all. It means it just needs to include A, B, and C. Meaning, by the way, if you have a patent claim directed to to an apparatus comprising A and B and C, and this is comprising, word comprising, that means that, as I said earlier, if a competitor practices or produces an apparatus that has A and B and C, they are an infringer. Even if they throw other stuff on top of it. Even if, in other words, they can't argue that, oh, yeah, it's true I have a light source, a detector, and a processor, but I also have a movable table and a conveyor belt and a bell and a whistle and all kinds of other things. Well, it doesn't matter. You don't get off the hook by adding more things. You don't become a non-infringer. You don't start with an infringing thing and become a non-infringer by putting something else on top of it or adding to it. And this is an important point.
I have a question.
Yes.
With respect to the all elements rule,
Yes.
does that trump the doctrine of equivalence?
Doctrine of equivalence is something different. Okay?
I wish I hadn't said that.
The doctrine of equivalence is something different. Just to define it, when let's say that your competitor did not have actually A, B, and C. Oh, okay, doctrine of equivalence has to do with infringement also. Okay?
John, 5 minutes?
5 minutes?
Yeah.
I'll stop whenever you want.
Yeah, all night long.
Yeah, I thought this was only going to last about 20 minutes.
So,
Wow, that's fast.
Yeah.
All right. But let me just answer the doctrine of equivalence quick definition for it. I've already explained to you about the all elements rule. You have a patent claim and you are claiming A and B and C. Therefore, if somebody is practicing A and B and C, they are an infringer. But let's say that they have A and B and C prime. Let's say that your actual patent claim is where C is a spring. Okay? A spring device. Okay, spring. We'll just leave it at that. And so, and in your drawings and in practice, you show a coily thing like that. All right? So one of your competitors builds something that has A and B, and rather than a coily spring, they put in a rubber band. All right? So the question is, the phrase that we're using is the doctrine of equivalence. Equivalent, with a T at the end, equivalence. The question is, does that competitor's product perform substantially the same function in substantially the same way to get substantially the same result? If the answer is yes, yes, and yes, then the argument is probably, there will probably be a finding of infringement because they did something that produces this, that did substantially the same way, substantially the same result.